to Snark Chocolate, a show about ZK products, where we break them down with rich flavors and sweet insights. My name is Omer, and today we're thrilled to be joined by DC Builder, research engineer at the World Foundation, the Real Human Network. DC, it's great to have you here.
Thank you for having me. Pleasure to be here.
To kick things off, could you please introduce yourself and the World Project?
Sure. So I go by DC Builder online. So my role is a research engineer, but it's sort of like a casual role. I do a mixture of different things. So at the World Foundation, we do different parts of the sort of general scope of the World Project. So maybe let me start with the World Project, and then I'll introduce sort of my role within that. So World is building the largest identity and financial network in the world for real humans. And so, in a world where it's really hard to tell apart what is human, what is an AI, because the age of AI is essentially getting more and more real, where any content that is generated online is really hard to tell apart whether it's generated by a real human being or an AI, because LLMs and other machine learning models are getting a lot better at generating content that is indistinguishable from that of a human being. So World is building solutions to essentially make the internet more human, allow you to use it as the way as we've used it so far, by building different identity tools and financial tools. So one of them is the proof of personhood, which is essentially a way to prove that you're a unique human online and on chain with full privacy preserving guarantees. And so the other one is just like giving everyone access to self-custodial finance, right? So like through crypto, through a smart contract wallet on blockchains. And so my personal role is mostly like that of a coordinator across multiple work streams. My personal interest is applied cryptography and ZK. So I've been working at the intersections of a lot of these fields. Anything that touches like blockchain engineering and applied cryptography, I'm generally well versed in within the project. And I've worked in a lot of different side of things. So when I first joined the project almost 3 years ago, I was a research engineer at Tools for Humanity, which is the other entity. And I was on the protocol team, so I was working as a Solidity and Rust engineer, working a lot of the smart contracts, Solidity smart contracts for World ID, which is our identity protocol. And now I'm at the World Foundation, where I mostly worked on the grants program. So essentially working with third parties and giving grants to different third parties to work with them like on different cryptography topics like MPC and ZK. And nowadays, I mostly work on Worldchain data specific things and identity tooling. Yeah.
Okay, there's a lot to unpack here. I guess that to start with, I actually want to ask you a personal question. So, knowing you, you could have probably worked on many different things, and also just relaxed at the beach. Why did you choose to work on this project specifically?
So when I was looking for opportunities back in 2022, I was looking at several projects. I was looking at like Optimism, Matter Labs, ZK Sync team. I was looking at Flashbots and World. Those are like the four things that I was looking into. So the general like topics that I was interested in at the time were blockchain scalability and Ethereum core specific topics. And I just got really interested in cryptography at the time. I worked at a project prior called Alongside, which does crypto market indexes. And one of their decentralized products they wanted to build is like a decentralized index using MPC for owning shares of different wallets. And just those would rebalance an index. So essentially, I got really interested in cryptography at the time. And I got pilled on ZK by watching some lectures online on YouTube. And as I dove into that, I wanted to work on something where I could get better at ZK or just like work within that domain. And so World, when I first saw it, it's sort of like a perfect match for what I was looking for at the time. It's something where I was able to work on all the specific topics that I was interested in. So Ethereum, digital identity, cryptography, Ethereum scalability. And also at the time I met the team, it was really impressive just how ambitious and like the talent density of the team was insane to me. And also just like the talent was not just talent in a specific domain like blockchains, but it was a talent pool that was spread across so many different topics from hardware manufacturing to firmware, to AI biometrics, to cryptography, to protocol engineering, to app development, and like building a real product that scales to millions of people, just like a Web2 company would. Because a lot of the people that came originally for the founding team are Web2 people, and like they built startups before that reached millions of users. And also like Sam is one of the co-founders, Sam Altman, co-founder and CEO of OpenAI. So when I met the team, it was like really impressive for me, just like how many talented people were working on this. The fact that you also have like good funding and you're actually able to reach millions because you have experience building these products. And for me personally, it was a great growth opportunity because I could work on all the things I was interested in learning more about. So that being ZK and blockchain engineering in general.
Yeah, so World is known as one of these projects with massive number of users. And I would like to understand what, in fact, they are able to do. I guess beforehand, it would be useful to also learn. You mentioned tools for humanity and the World Foundation.
Mm-hmm.
So, how would you define both, or what is the difference, or the division of responsibilities between these two
Mm-hmm.
organizations?
Sure. I mean, it's a classic structure in crypto, at least, where you have a labs entity which does a lot of the heavy engineering and all the product building, and foundations usually handle a lot of the things around decentralization, treasury, some legal, grants, these sorts of things, right? So TFH essentially manufactures the orbs, they distribute them, they hire operators, they build the world app, they build the protocol, they're the founding team that created the project, that created World. And the World Foundation is an entity that helps usher the decentralization of the project, right? So working with different third parties that collaborate in the project, in the World network, to build all the different components, and eventually like, so you don't have a single point of failure in the entire line of all the different products and everything that you're building. But that is a long-term mission also because it's hardware, so it's like hard to decentralize. But yeah, that's the sort of that's the differentiation between the two orgs.
Okay, great. So now, talking about these components, right? There's like a wallet, a blockchain, the orb, hardware. Can you kind of like break it down in a clear way so that we'll have a good model understanding of some kind of like overview of what exactly is included in this project?
Sure. So I guess the best way to start is reverse engineering the user experience when they first join the project. So the way that the user flow would be like is that, hey, I am a unique human and I want to verify myself to be a unique human. And so I want to prove that I'm a unique human. So what I would do is I would download the World app. The World app is a client for anything in the World project. So when I download World app, it generates two things. It generates a World ID and it generates a World app wallet. So the World app wallet is a safe smart account that I can access just as any other wallet. It's a self-custodial wallet with a 1 out of 1 signer. And it's a safe, right? So safe smart account. And the other part is the World ID. So World ID is just a private public key pair. And essentially when you go to the orb, which is this hardware device that allows you to prove that you're a real and unique human being, there's two different components. It essentially verifies your public key to belong to a unique human, essentially. It inserts you into a set of verified people, and then you're able to ZK prove that you're in the set of verified unique people. And on the other side, right, you have the safe smart account. So these are the two main things. The World app, a safe smart account, is deployed on Worldchain. So all of the users that we have, which are over 15 million, I believe, right now as we speak, that are orb verified, and 25 million that are that have downloaded the World app across iOS and Android. So those users, all of them have smart accounts on Worldchain, which is an OP Stack L2 part of the superchain. And so those are the three main products, right? You have World app. Within World app, you have access to World ID and the Safe Smart account, which both live on Worldchain. And maybe also like the other thing is I can mention is Worldcoin, which is the token. And that one is essentially a token that is fairly distributed to all of the users that have a World ID because they can claim tokens every month by proving they're unique human. of course, within the countries that are eligible for the grant. Yeah.
Understood. So, talking about grants, you also mentioned that you are involved in World Grants. Maybe you can give us more color on how the process, how the system works, for specifically for grants.
Yeah, so currently the grants program is undergoing like some restructuring, but I'll sort of give the context for what it's looked like up until now. So the grants program essentially is an incentive structure for third parties to help us solve some of the hardest problems in the ecosystem. So we had a list of requests for proposals, or RFPs, that sort of range across various fields. Some of them are around cryptography, so things like ZK or MPC problems. So to be more concrete, one of them was, for example, for doing PIR, private information retrieval from a database. Some other ones were around client-side proving or proof aggregation to minimize the footprint of ZK proofs on Worldchain. Then some others were more like user experience focused, so things like passkeys for smart accounts, like passkey signers, or just like for account abstraction type related ones. So these are like more user experience. There's like different categories. Other ones were like orb hardware and firmware related. Some of them are voting mechanism design, right? So they're like now you have person who you can design different voting mechanisms and incentive structures. That's another interesting one. And just like general like data analytics or like porting World ID to a different network. There's like a lot of these different topics. And so the way that this grants program worked is that you can apply for any of these RFPs, and we'd review that proposal. And after that, we would just do a grant agreement with that given party after doing the review and agreeing on the scope. And we worked with those different teams to implement different features or part of the RFPs. So, for example, like one of the best examples of this was working with the Tasio team, whom did a lot of our MPC work together with the Tools for Humanity, the World Foundation, and the Inverse Tech team. So they implemented our entire MPC sort of implementation for working on the privacy preserving biometrics side of things.
Yeah, looking at the list, it seems like some of the best teams in the world participated or are participating in this program, which is interesting. Maybe you have some insights into how this came to be, or some other examples for like interesting projects that are in the works or came out of this grants program.
I mean, I would say that the most interesting one would definitely be, or like the most important to the project was definitely the Tasio one. Some other teams that we've worked with are, for example, Nethermind. For some research around zero knowledge machine learning, we also did an implementation of World ID for Starknet, for example, with them. Then we also, for example, worked with. Actually, let me just pull up the list. It's hard to remember everything from memory. So we have two different pages. There's the Wave 1 and Wave 0 grants that we gave out. One team that we worked with is Nibra for proof aggregation. So that is actually coming to production soon-ish, where you're able to do aggregation of Groth 16 proofs on Worldchain, as opposed to submitting like hundreds of individual Groth 16 proofs. You can just verify one aggregate proof of a batch of proofs, which greatly minimizes the use of call data and execution gas on the L2, which is great because we have millions of these every month. Also, we worked with teams like Nethermind, like I mentioned, Tasio. For Wave 1, we worked with teams like Axiom, which also did an implementation of the aggregator as well. Teams like Cometh, who built a lot of the libraries that we're using for passkeys and safes. Wormhole for doing a Solana implementation of World ID. ZK Snap, which is a great end-to-end private voting protocol that has a SIB resistance, collusion resistance, and private voting. Yeah, I'd say like those are some of the notorious ones that we worked with.
Another interface of this project of World is partnerships. So recently, for example, I've seen this announcement on a partnership with Razer ID, which is kind of like a Web 2 thing, right? It's like breaking out of the Web 3 ecosystem. So I'm curious how such partnership came to be, maybe even more generally, and how it looks like technically.
Yeah, for sure. Some of our biggest propositions is essentially to solve real world problems, right? We're not just necessarily confined to Web3 per se. So how Razer ID came to be is that we're talking with a lot of different partners, and many of them like face the frustrations of churn in different kinds. Where in the case of gaming, it's really frustrating for gaming players, like video game players that are playing in the competitive scene, that they are playing constantly against bots or humans just like running accounts that like have bots on competitive games, and it's really hard to play those games, right? Like usually you have some anti-cheat system, but even if you're playing the game and you have like anti-cheats, and let's say you're like playing CS:GO, you have like an anti-cheat system that will detect things like wall hacks or just like automatic headshots and stuff. You don't have a good way to bind violating rules to a given person, right? So if, let's say like if I play competitive games with a bot, um, I will, for example, get my account banned, but I can always just create a new one and start playing competitive games and do that again all over again. The problem is like as AIs get better and these tools get better and like anti-cheats essentially have to struggle with more and more things, it essentially breaks the trust of competitive gaming, and not just competitive gaming, just like any gaming. Like humans don't really want to play against bots; it's not fun. Um, and so Razer ID is built by Razer, right? Like the gaming company, they make gaming hardware of different kinds and also software. And so the problem space is that, right? Like I want to play games and I want to make sure that the person I'm playing against is a human and is not a bot. Or for example, if they use some cheats, then we're able to have track, for example, who's used cheats before. And so you have some form of accountability for video game players. And Razer ID is one such solution where a gamer can create an account with Razer ID, and a video game developer can integrate Razer ID to make sure that the people playing the game are unique humans.
So they have their own identity system. You have an identity solution. How is it going to work together?
So if you have a Razer ID, you can just generate an account on their website. You can verify that account to be a unique human using World ID, so you can do your proof of personhood, and then your Razer ID will be World ID verified. And the first game that is launching with this solution is called Tokyo Beast, which is a game coming out of a Japanese game developer. And so users that are going to have like Tokyo Beasts accounts, they can log in with their Razer ID, and then when they're playing in competitive games, then you'll know that like, hey, this is unique human verified. Of course, this is like just the beginning, right? Like there's going to be more and more solutions, and eventually there's going to be more and more people, and it's going to become more useful. There's different kinds of solutions, right? Like because even if you like for example know that this account is operated by a unique human, that doesn't give you the guarantee that the person is not using some software behind the hood, that even if they're verified, like they're not cheating, right? So eventually there's going to be like more and more solutions for these things, but that's the current state of things.
So this means that this World ID is something that you can basically share, use. Like there is some like as a developer, right? If I'm a game developer, for
Mm-hmm.
example,
Yeah.
how can I
Yeah,
use
World ID is
this
an open
World ID?
source. Yeah, World ID is an open source protocol, and we have an SDK, so you can either use it on chain or you can use it as an API. So the API use case is called World ID Cloud, or you can use the on-chain verifier. You can verify the World ID zero knowledge proof either in a server or in a smart contract, right? And so if you're building an off-chain application, anyone can build, for example, like a general like login system, like you have, for example, like Razer ID, and one entry in the Razer ID would be verified in an off-chain API that like, hey, this proof belongs to a real human being. And the way that World ID works is that you have a nullifier scheme, and this allows you to essentially track that each individual has only done an action only once, while still being fully anonymous because the hash is pseudonymous, right? And the zero knowledge proof hides the public key that you're proving the ownership of. So yeah, so it's fully privacy preserving. You can either do it for on-chain or off-chain applications of any kind, and it's fully permissionless.
Very nice. Which leads me to the next question, this privacy preserving part. So last year, you and I, we've been chatting about like different opportunities, and one thing led to another, and now my team is collaborating on this like crazy client-side prover project. Maybe you can share more about like the motivation of this project, roadmap, and more details in general about what's happening there.
100%. Yeah, this is like my most exciting, or the project line that I find most exciting at the project currently. So in the context of cryptography, right? Like if you look at the distribution of our users, right? So if we have 25 million users for World App, let's say 15 million roughly are verified by the orb. Each of those users needs to create a zero knowledge proof whenever they're using World ID. Currently, it's a very simple Merkle inclusion proof. So essentially, World ID, the way it works is that, hey, I have a set of verified humans, and this set is implemented as a Merkle tree. And you have a Merkle tree of public keys. The protocol itself is called Semaphore. It was built by the Privacy Scaling Explorations group. And so this proof is very simple because you only have like 30,000-ish constraints, and you can prove that in very low-end devices very fast and with no issues. The problem comes when you're doing more elaborate digital identity use cases. So let's say I want to create a proof that I own a unique passport, or that you have like selective disclosure proofs of like verified credentials, right? So in the case of passports, like I have let's say a structured, let's say a JSON, just for simplification. I have like a JSON object where you have like keys and values. So I have like name, surname, date of birth, age, and this sort of structured data field or data structure, I can just sign, also like hash, and then sign the hash. So I commit to that data and I sign the commitment, or that's usually how digital identity systems work. And if I want to create a proof of this, a ZK proof of that, I have to do a hash function and a signature in circuit. And all the digital identity systems that have been built out so far, they never were built out with ZK in mind. So the overhead of creating such proofs is really, really high because you have like millions of constraints. So for us, we have a lot of like very unique constraints when it comes to building such a system. Because we have lots of users. Those users are very widely geographically distributed. We're, I think, live in like 36 or 35 plus different markets. And so if you look at the distribution of users, if you look at the 99th percentile of it, it's usually like some like old Android phone that has like 32-bit, has a 32-bit architecture. They have like 2 gigs of RAM, very low bandwidth. They have essentially a really old phone, like really old Android phone that is very low powered, and the specs are very bad. So when you have to do cryptography that is state of the art, like ZK cryptography that is state of the art in these devices, you face specific constraints that no other project faces because you're doing cryptography at scale and in user devices that are very low powered. So this is sort of like what led to the developing of a new client-side proving stack. So what we're doing there is that we did a lot of research into like the entire stack, right? So from the constraints, and we reverse engineer the constraints to figure out what works there. And so we were looking to essentially go from first principles and see what works there. So the main constraints, as I mentioned, or like the sort of technical ones, are that we want to prove a circuit that is bigger than 2 to the 24 or 2 to the 24-ish constraints, so 16 million constraints in less than a minute, in a device that has around like 1 gig of RAM available sort of memory for this process. And you essentially cannot do things like delegation and other things because the bandwidth for upload and download is really small. It needs to be transparent because we don't want to download like trusted setup files because it would increase the binary size. For Groth16, if we wanted to do like Groth16 circuits, it would make the binary just gigantic for World App, so it would be impossible to fit that in. For Semaphore, it works because it's a really small circuit, but for things like proof of passport, we call it World ID credentials, right? So like for things like selective disclosure of signed credentials is really hard. And so yeah, like the solution that we ended up coming up with is using the Spartan proving system, which is really fast and transparent client side with the where polynomial commitment scheme, and then we recurse that into Gnark, and we create a Groth16 proof server side once we have soundness and ZK client side. And the programming language, the front end for writing these circuits is Noir. So that's sort of the general gist of the stack, right? So we go from Noir to the Spartan where, then we recurse that into Groth16 and verify that on chain in the EVM.
So just saying it in my own words, basically this is some kind of a language for proving identity properties with Noir that has to run client side with all sorts of like constraints because it's identity. Is that kind of like a good way to frame it?
Yeah, so
Okay.
so Noir is a really popular ZK DSL, and so what allows you to do is like just write circuits really fast and with really good developer experience. And so for us, the use case that we're interested in is just general statements about your identity. It can be about your KYC identity, right? Like in a fully privacy preserving way. It can be about things like web proofs, ZK email. You can create proofs of arbitrary data and fully client side, right? So you can have fully privacy preserving digital identity, and all of your data is still owned by you on your own device, and all those proofs are created client side. And the good property of the system that we are building is that all of those things can run on low end devices, which means that these solutions can be widely deployed to our entire user base.
Oh, good. Yeah, this is going to be like a fantastic prover, like really bleeding edge stuff all across the board. I guess it's a good opportunity to ask about, like, in general, the roadmap for world.org. If there's any kind of like hints or milestones that are upcoming and you can share with us, maybe, I don't know, like new partnerships and so on, or directions.
Mm-hmm. Yeah, so the thing that we're focusing on for this year mostly is growth, right? So like being able to grow this project to something that everyone everywhere can use. So one of the things that we announced in our latest keynote in October of last year was a new generation of orbs. So the new generation of orbs are more easily manufacturable. They're built for scale, essentially for mass production, and we're opening lots of locations in lots of new markets throughout the year. So that's sort of like one of the recurring focuses for us, because the more users you have, the more useful the product becomes for everyone. So the sort of general gist is if you want users to adopt World ID, then it needs to be useful for them. And the overlap of your user base and their user base, sort of like the World ID user base and the user base of any product or project or smart contract that wants to integrate World ID, needs to be substantially big, so that they're actually able to benefit from using World ID. And so growth is sort of the recurring focus for us. Then to enable these new use cases, such as like selective disclosure, we're working on things like client-side proving. So building the entire infrastructure for allowing you to build digital identity proofs of all kinds at scale. That's another big focus. I would say general like scalability, but not on the terms of growth, like technical scalability, right? Like scaling Worldchain, the L2, and helping the Ethereum network scale as well whenever we can. There's a lot of focus also on mini apps. So mini apps is this feature in World App that allows third-party developers to tap into our user base. So any third-party developer that wants to build a consumer app and target like all of our users, the 25 plus million users that have World App, they can build this mini app, which essentially allows you to tap into all the World App SDKs and APIs. So you can use World ID, you can trigger a smart contract transaction from the wallet, you can sign arbitrary data. So that's another big focus. There's lots of mini apps that are growing really fast and that have hundreds of thousands of daily active users, which is awesome. Um, so I would say those are like three really big ones. There's of course like a bunch of others, but I believe that those are at least the ones that I currently am most excited about, and we'll definitely like share a lot more throughout the year.
Thank you. Appreciate the transparency, and seems like very interesting challenges to tackle. I want to talk about the orbs for a second, or maybe about the fact that since you're working or operating in this identity space, you're likely facing some risks, right? One is that you are collecting biometric data as part of the system. What are the risks? I mean, try to, if you can educate me on what risks are involved in just working with identity. How did you solve them? Do they still exist in your system, and so on?
Yeah, I'll try and give a general overview. Maybe I can also like point to the longer form format if people are curious about the actual like really detailed technical version of this. That is in the World white paper. So if you go to whitepaper.world.org, you can find a lot more details there. But I'll give the general gist as well. So the way that our sort of privacy implementation for sort of like general like the project. So essentially like the way that proof of person works is that you have the orb, and the orb does two things. One is to prove liveness, and then to prove uniqueness. Liveness is being proven by having lots of different sensors, things like light, field of depth, heat, and others, which essentially allow you to prove that the person that is standing in front of the orb is a real person, right? Like they're not wearing glasses, they're not wearing contact lenses. You know that they have a 3D face that looks like a human, doesn't look like a child. That they have like a continuous heat map. There's no occlusion. They have their eyes open. So that's the realness part, which essentially is done by the orb when you're being verified. And the second one is the uniqueness. So once you prove that the person is real and is actually standing in front of the orb is also secure hardware, right? So it's not able to be like all of these sensors are not able to be mocked or like tampered with or somehow uh, like let's say you do like an adversarial attack against the orb. That's sort of like why you need the custom hardware. And the second is for the actual uniqueness part. So the way that the unique identifier is computed is through this thing called a Gabor filter and a Gabor wavelet. What you can think of it is that when you go to the orb, it will compute a uniqueness representation or a representation of the randomness of the information that is in the iris. And this is called an iris code. This iris code, depending on how you want to view it, is sort of like a unique representation. And this iris code, you can compare it against the set of existing iris codes of all the people who have verified to date. And if the distance or the difference between your iris code pair and the other iris codes pairs is greater than some threshold, then you know that that person is unique, right? So if you assume this is sort of like the how you measure the uniqueness part. Now, when it comes to privacy, like how do you make sure that this process is fully privacy preserving and does not reveal any information about the user throughout the entire process? That's where cryptography comes into play. So for the proof of uniqueness, we use a flavor of MPC, multi-party computation, where the iris codes are never stored in plain text. These iris codes are split into three different shares that are operated by three different nodes. These nodes are operated by different universities. One of them is the University of Zurich, the other one is the University of Erlangen, and the third one is the University of UC Berkeley in the United States, the RDI department. And so what you do here is that you split the original iris code pair, right? You have two irises, into three different shares, and each of them is held by a different node. And then when you're doing the uniqueness check for every new user, for every new iris code pair that is computed by the orb, you will do a linear check in this MPC database. But when you're doing this check, you never have any of these in plain text. The query, which is the iris code pair that you're looking in the database, is an MPC in this linear secret sharing scheme. And all of the other entries in the database are also a linear secret share space in the MPC space. And you're checking the distances between the query and all the entries, like the 15 million user entries, or I think it's like 11.5 million or something like that. I would have to check the world.org. Let me just quickly just check the number because I don't want to hallucinate the number. Yeah, it's 11.7 million users that are verified by the orb. So you do the check against the 11.7 million entries, and if the distance between your iris code and all the others is greater than the threshold, then you insert that user into the set of verified people, and their public key gets inserted into the Merkle tree, which is on chain, right? So this is sort of I know that's like quite technical, but this is like how we enforce privacy on the biometric side. And then when it comes to the protocol side, we use zero-knowledge cryptography to prove inclusion in the set. So every user that is verified by the orb, they have a public or public-private key pair, and they're able to prove that they own a private key to a public key in the set of verified users in the Merkle tree, without revealing which public key they own. So you essentially have end-to-end privacy here, where no information about the user is ever public or in plain text, and everything they're doing is just proof the ownership of a public key, essentially, and that's like how we ensure privacy. So I guess the challenges here is how do you explain these things to a different set of audiences, right? There's regulators, there's users, there's cryptographers, there's just general developers that use World ID. And so some of the challenges have come from just explaining these technical solutions to different audiences. And while working with them, these solutions also change and advance and get better. So sometimes when some people think that something works in some specific way, we might have moved to something better. So it's always like a game of educating and moving forward and making sure that the system meets all the demands for all the markets that we operate in.
So this actually ties nicely many things that we talked about today. Just as a quick follow-up, I'm curious if there was, like PET's privacy enhancing technologies are also recognized to some extent by regulators, and it's like this ongoing kind of like effort from the legal perspective. Is there any kind of like interface between what you guys do and regulators, compliance, legal? Have you got to kind of like have discussions on that topic, on these topics?
Yeah, I mean, of course, like we talk with all the regulators from all the markets that we operate in. So, for example, in Europe, we are regulated by BLDA, which is the Bavarian Data Privacy Authority, and the European Union. So for Europe, within GDPR, you have one entity that you register with, and that one represents you for the entirety of Europe, in our case, or in just any GDPR case. And so, for example, Europe has even guidance that says if you want to build a digital identity solution, you can look into things like ZKPs. This is like in specific guidance around digital identity. You can Google it, you'll find it. So even the European Union is building a ZKP digital identity wallet themselves. It's open source. You can find it on GitHub. And so a lot of the sort of things usually, it's not like that they don't know how ZKPs work or how ZKPs are useful. It's mostly about the privacy guarantees from the biometric side, and it's really hard to couple sort of the general, like, how do you make sure that the biometric data that you use to generate the original sort of randomness representation, and how you make sure that that is private, and how you tie that in, like, sort of the full picture is the hard thing to give. The technologies on their own are fairly understood, but the hard thing is like give a holistic picture of the entire system and convince the party or the regulator that, hey, this is compliant with all the different constraints of the systems that you're building. or sort of like complying with all the constraints of the regulations that everyone has in different markets. And so of course, like it's a complex sort of interaction, and so it's always like we of course like make sure that we're always compliant with all the markets that we operate in, and we do a lot of education with all the different parties involved in the process.
Okay, so for my final question, I wanted to ask you about the acquisition of Modulus Labs. So this is a fantastic team working on ZKML, and I wanted to understand more how they got involved with tools for humanity and what they are working on right now.
Sure, 100%. So actually, ZKML is a topic that is really like near and dear to my heart. I in 2022, when I first joined the project, the first project I worked on was actually ZKML when I joined the team. And so ZK machine learning essentially is the application of zero knowledge cryptography to machine learning algorithms. So creating zero knowledge proofs of ML algorithms, right? In which specifically we care mostly about inference as opposed to training. So essentially the evaluation of an already trained model. And so we're doing some internal experiments into like the feasibility of even like running these machine learning algorithms in ZK. And by doing that, I wanted to talk to lots of different people at the same time, like and see like where they were at. I was part of different communities like the Zero Knowledge podcast community, and I decided to create my own group chat. So I created the ZKML community group chat back then, and I started organizing like monthly or bi-weekly calls. I don't remember. And when I created the group, I invited all the teams that were working on the topic. So I invited Ezekiel, Giza, Modulus Labs, and various others that were working on ZKML at the time. And through different conversations, we were chatting about the state of the art, what different libraries are good, how it works, what use cases people are excited about. And so we had a specific use case in mind for World and World ID. The use case that we needed is that when you have this iris code, it's really hard to do upgradability of iris codes and upgradability of the biometric system. Because if you ever change the algorithm for creating the iris code, you would change the entire vector space of the output of these iris codes. So if you change the algorithm, you would essentially force all of the users to re-sign up again. So you would lose all your existing users, and you'd have to require them to go to the orb again to essentially generate their new iris code. And so where ZKML would be useful here is that the orb will sign the original images that we'll take, and it will do a commitment to them. And the user would store those images and the commitment. It can be a signature. In our case, is a polynomial commitment scheme. And so when you store that with the commitment, you're then able to create a zero knowledge machine learning proof of the creation of the new iris code. And then you can use that to essentially upgrade the system with full privacy preserving guarantees without having to go to the orb again, right? So the users would be able to upgrade their world ID without having to go to the orb again in a fully like trustless, like we can just verify as EKP and the MPC set of verified users. And we know that it actually like the iris code was derived from the original data, from the original images that were taken by the orb in a fully like permissionless way without having to go to the orb again, which is great. And so Modulus Labs was working on these solutions with Tools for Humanity. We're like the biggest use case for what Modulus Labs was building at the time in 2022 and 2023 and 2024. And they were building this client-side proving library for ZKML called Remainder. Essentially is a GKR-based prover for doing ZKML. They were working on the specific implementation of the ZKML upgradability of iris codes for World ID. And so we started working with them more closely over time, and eventually it just made sense for them to become part of Tools for Humanity because we were working on the same vision and we're their biggest use case. And so we did an acquisition, and now they're part of the Tools for Humanity Applied Research Department, or TF-HARD, as we call it internally. And they're currently working on the on the project that you mentioned that you mentioned earlier, that you're also collaborating on, which is the client side proving efforts. So that's what the Modules Labs is working on currently. The Modules Labs team, or now TF-HARD, is working on. So it's the entire like Spartan, Noir tooling, Where tooling, and the entire end-to-end project management of this, where also Ingonyama is working on a lot of the low-level optimizations for different parts of the protocol.
Awesome. Very, very interesting. So DC Builder, with that, I want to thank you so much for joining us today. It was great to learn about all the different aspects of World Project, and hope to speak soon again and learn about your progress. For those interested to learn more, we've added some links in the show notes. Thank you, everyone.
Thank you very much for having me. Take care.